All right, so we're going to start off with electric circuits. Before we get into the questions, there's a couple formulas we need to know. Okay, V is equal to IR. That's one of the most basic formulas we're going to be using, where V stands for voltage, I is your current, and the unit for voltage is V, okay? Unit of current is amperes. It's usually written by A. Short form of amperes is A. R is your resistance, and the unit for resistance is ohms, OHMS, but they're usually represented by the symbol. Okay, that symbol looks like this. Okay, so this is the most basic, the most fundamental formula that we need to know. Voltage is equal to IR, means voltage is equal to current times the resistance. Now, apart from that, there's a few other formulas, and obviously you can move things around to get I. I would be V over R. Similarly, R would be V over I, okay? I'm sure you guys can move things around and isolate each one of these variables. Now, along with that, there's a few other formulas you will need to know, okay? Especially for P, power. P stands for power. And unit of power is watts. Short form is W. And power can be written as VI, voltage times current, or it can also be written as I square R, current squared times the resistance. Okay, that's another formula I want you to remember. Okay, so folks, I strongly recommend you to remember these formulas off the top of your head, okay? It's going to save you lots of time. Now, we're going to talk about series circuits. Okay, we're going to talk about circuits which are in series. What do we mean by that? Typically, what's going to happen is you're going to have a voltage source. This is the symbol of the voltage source. And let's say it's giving you 10 volts. And then you will see a couple of resistors in the loop. And I'm just going to make up some values here. 1 ohm, 1 ohm, 1 ohm. Now, guys, I want you to think about this voltage source, okay? I want you to think about voltage source as your pump, a water pump, okay? Voltage source, think of it as a pump that's going to push some water out of it. A voltage source is going to push some current out of it. A pump pushes water out of it. Voltage source pushes current out of it. And I want you to think of current as water. Okay, current is water. And these resistors, think of them as pipes. Think of the resistors as pipes, which allow the water to flow through them. Okay. Now, let's talk about it in terms of a pump. Folks, you have a pump. It's going to push some water out of it. The water flows, right? Water flows. It goes through the pipe, goes through this pipe. It goes through this pipe. It goes through this pipe, and it comes back, and it keeps flowing. Now, I have a question for you. Let's say if 4-liter water was pushed out of this pump, how much water is going to pass through this pipe? 4 liters is going to pass through this pipe, right? How much water is going to pass through the other pipe, the second pipe? Well, they are in the same loop. They're in a series. So the same 4-liter water is going to pass through it. And the same 4-liter water is going to pass through this resistor. Pretty much you have 4 liters of water passing through all the pipes. Now, what does that tell you? That tells you that these pipes are in series. Means water is not splitting anywhere. It's just one path, one circuit, one series, and the same water is flowing everywhere. Now we're going to go back and think about it in terms of current. Okay? We've thought about it in terms of water. Now we're going to think about it in terms of current. Okay? You have a voltage source. It's going to push some current. The same current is going to flow through this. The same current is going to flow through this. The same current is going to flow through this. Whenever the same current flows through this, in other words, all the resistors are in the same path, current is not getting split up, you can say they are in series. Okay, so now we can say that these three resistors are in series. And whenever your resistors are in series, you can get your total resistance by just adding up all the resistances. R1 plus R2 plus R3. Remember this formula. When your circuit is a series circuit, you can find the total resistance by just doing R1 plus R2 plus R3. Okay, this is your series circuit. Okay, now another thing I want you to remember is what happens when current passes through the resistor. What happens to the voltage? Guys, this voltage is technically voltage difference between these 2 points. This is the first end of the terminal, this is the second end. And the voltage difference between these 2 points is 10. Now look, as long as nothing is in between, the difference will stay 10. So from here to here, voltage difference is 10. But what happens is when your current goes through a resistor, there's going to be a voltage drop. Okay, when the current goes through a resistor, there's going to be a voltage drop. You know how much that voltage drop is going to be? What's the voltage drop across the resistor going to be? Remember the formula? IR. Current times the resistance. That's going to be the voltage drop. And I'm going to show that to you in a bit. Okay, voltage is going to drop here, and then it goes through this. So there's going to be another voltage drop here. That's going to be I times R, where current that goes through this times this resistance. Okay, these R values could be different. And same as it goes through it, there's going to be voltage drop here. It's going to be I times this R value. Now, there's another interesting thing. If you sum up all the voltage drops, it will be equal to the total voltage. So the total voltage will be voltage drop on resistor 1 plus voltage drop on resistor 2 plus voltage drop on resistor 3. Okay, whatever drops here, whatever drops here, whatever drops here, if you add them up, it should be equal to 10. Okay, these are the characteristics of a series circuit. Remember that. The main thing to know is in a series circuit, your resistance total is R1 plus R2 plus R3. Now, we're going to solve this question. We're going to find the current, we're going to find the voltage drops, we're going to find the power in each of these circuits, in each of the resistors. Okay, so let's do that. I'm just going to clean this up a bit, and then we're going to actually solve this circuit. Okay, guys, first of all, I look at this and I realize, I say, this is a series circuit. Okay, so what's my total resistance going to be? My total resistance is going to be sum of all these resistances, right? This is a series circuit. So total resistance will be R1 plus R2 plus R3, which means it's going to be 1 plus 1 plus 1, which is equal to 3 ohms. Okay, I'm actually going to change this up. I'm going to make this 2. So now my second resistor, instead of 1, it's actually 2. So we have 1 plus 2 plus 1, which is 4 ohms. My total resistance is 4 ohms. What's my voltage total? Well, we know voltage total is the total voltage applied by the source, which is 10 volts. Then I can find my current total. My current total is going to be voltage total over resistance total. Why? Remember the basic formula? V is equal to IR. From there, you can say I is equal to V over R, right? So I total is V total over R total. So what's that going to be? It's going to be 10 over 4, which is 2.5. 2.5 amps, because the unit of current is amps. Now, what does that mean? It means the current that goes out of this one, this voltage source, is 2.5 amps. That means, okay, if this is my resistor, 2.5 amps is going to flow through this resistor. And the same current is going to flow through this resistor, 2.5 amps. And the same current is going to flow through this resistor, which is 2.5 amps. Okay? This is the resistor symbol, by the way. Now we know the current that flows through each of the resistors. Now that we know that, guys, what we can do is we can find the voltage drop at each of the resistor. Now, what's the formula for voltage? IR. So I can do IR to find the voltage drop here. I times R. So folks, 2.5 times 1 will give you 2.5 volts. 2.5 volts dropped here. Over here, the voltage drop will be IR, 2.5 times 2, which is 5 volts. Again, voltage drop here will be IR, 2.5 times 1 is 2.5 volts. Now look at this, 2.5 plus 5 plus 2.5 is 10, and your total voltage is 10. Okay, so that makes sense. I found all the voltages now, voltage drop at each of the resistor. And now how can I find the power loss at each of the resistor? We know power is VI. That's the formula for power. Okay, remember that. These are the formulas you're going to have to remember. So to find the power drop at each of these resistors, I can do VI. Okay, so let's do that. V is 2.5 times 2.5. 2.5 times 2.5 is 6.25. So power on this resistor is 6.25 watts. Power on this resistor is again VI. So that's going to be 5 times 2.5, which is 12.5 watts. That's the power loss on this resistor. And power loss on this resistor will be VI again. So 2.5 times 2.5, which is 6.25 watts. Okay, and the total power, we can get that by doing voltage total times the current total, which is 10 times 2.5. So my total power is going to be 25 watts. That's the power of the circuit, okay? That's the power of the circuit right here. That's my power total of the circuit. 25 watts means the circuit is supplying a power of 25 watts. Now, another thing interesting about power as well, power drop at each of the resistor, if you add up power drop at all the resistors, it's going to be equal to the total power supplied by the source, which is 25. 12.5 plus 6.25 plus 6.25 gives you 25. Okay, so there we go. In this series circuit, okay, in this series circuit, we've learned how to find our resistance total. We've learned how to get our current total, and we've learned how to find the voltage drop and power drop at each of those resistors. Okay, this is an example of a series circuit. Now, let me show you an example for a parallel circuit. Okay, next up is our parallel circuit. So imagine I have a voltage source, 10 volts. But now my resistors look like this. Let's say this is 2 ohms and this is 4 ohms. Okay, guys. Again, think about water. This pump pushes some water. The water flows here. At this point, what happens to that water? It gets split up, right? So you see, now you don't have the same water flowing through these two resistors. They're not in the same line. They're not in the same path. Water got split up. Whenever water gets split up, whenever your resistors are not in the same path, you can say they're parallel. And whenever you have a parallel circuit, your resistance total is given by this formula. 1 over resistance total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 dot dot dot. If there's more resistors, you would keep doing 1 over R4 dot dot dot. I like to write it like this. R total is going to be 1 over R1 plus 1 over R2 plus 1 over R3 dot dot dot, all raised to the power minus 1. When you do that, you see this is the reciprocal. At the end, you're going to have to do that anyways. But by writing the formula like this, it makes it even more clear. Okay, it saves you that extra step. Okay, so the first thing is these two resistors, I know they're in parallel, so I should first find the resistance total. So that will be 1 over R1, which is 1 over 2, plus 1 over R2, which is 1 over 4, and then all raised to the power minus 1. That's me doing the reciprocal. So 0.5 plus 0.25, and then we take the reciprocal of it. Okay, and if we write it, so folks, how do you do this? So 4 times, get the common denominator. You have 4 plus 2, which is 6. And common denominator is 4 raised to the power minus 1, which is 3 over 2 raised to the power minus 1, which is essentially 2 over 3. Okay? And 2 over 3, okay, if you punch it in, you get 0.67. We got 0.67 ohms. We got the resistance total. Now we can get current total, which is voltage total over resistance total. Current total is 10, and my resistance total is 0.67. Okay. So folks, 10 divided by that gives me 15 amps. So now I know how much total current came out of the voltage source. That was 15 amps right here. And then it got split up, right?
Sorry, the resistance total is half plus 1 over 4, right?
That's right.
And how it's become 6
Oh,
over 4, I think.
Okay. You know, you could have just done it 2 over 4 plus 1 over 4.
Oh, okay.
Okay.
Oh, okay.
So let me I think there could be a mistake here. We get the common denominator. So we get 2 over 4 plus 1 over 4 inverse, which is 3 over 4 inverse, which is 4 over 3. Yeah, good eye over there. So this is 4 over 3 ohms. And 4 over 3 is 1.33. Good eye. Then we come back over here and we say it's going to be 10 divided by 1.33. And that gives us 7.5. Okay, so it's 7.5 amps which comes out of this. This is 7.5. Okay, so now this is 2 ohms. This is 4 ohms. Okay, we know the total current that's coming over here, but I know it gets split up. Some of it goes this way, some of it goes that way. How do I know how much goes this way and how much goes this way? Well, there's another thing interesting about parallel circuits. Okay, let me show it to you. Okay, folks, look at the voltage here. It's 10 volts, right? Voltage is 10 volts. What that means is the voltage difference between this point and this point is 10 volts. Guys, if I just drag these points right here, was there anything in the path? Nothing in the path, right? That means the voltage difference across these 2 points is also 10 volt, means voltage difference across this resistor is 10 volt. If I drag these points right here, nothing is in the path. If I drag this point right here, nothing is in the path. That means the voltage difference across this resistor is also 10 volts. Now look at this. We found the voltage at all of these resistors. And now I can find the current because my current is going to be just V over R. When you do V over R, I get 5 amps here, 10 over 2. When you do 10 over 4, you get 2.5 amps. And you know, a total of 7.5 amps came in. 5 amps came this way, and 2.5 amps went down this path. So there we go, folks. Okay, we found all the voltages and the amps. Now they might say, okay, what's the power supplied by the circuit? So you say power total is V total times current total, VI. Okay, my voltage total is 10, and my current total was 7.5. My current total is 7.5. That means we have 75 watts of power in there. And what would be the power drop at each of the circuits? Again, you can do VI for those. Okay, 10 times 5 gives you 50 watt. 50 watt power loss happens in this 2 ohm resistor. And VI for this, 10 times 2.5 gives you 25 watts. So 25 watts of power loss occurs on 4 ohm resistor. And 50 plus 25 is 75, which is the total power loss. So far, we've seen our series circuit and a parallel circuit. Next up, what I'm going to do is I'm going to combine them. So let's say this is 10 volts. I have a 1 ohm resistor here, and then a 2 ohm resistor here, and I add another 4 ohm resistor. And then I add a 1 ohm resistor here. Now, if you look at this, this is a combination, okay? So what happens is current is pushed by this. The same total current goes through here. However, at this point, it gets split up. Half of it goes this way, half of it goes that way. At this point, they join back in. So this current and this current joins back in, and the same total current goes through this resistor, and the path continues. So it's super important to visualize what's happening here. Now, straight right off the bat, I know one thing, that when I got to this point, my current gets split up. That means this 2 ohm and 4 ohm resistor is in parallel. So what we're going to do is, I'm going to find the combined resistance, which is essentially the combined parallel resistance for these two. So the combined resistance will just be 1/2 plus 1/4, and then we take the reciprocal of that, okay? So this is again going to be 3/4, and reciprocal of that gives you 4/3 ohms. Now, to simplify your calculations, what you can do is, you can redraw the circuit. So we can redraw the circuit. This is 10 volts. It goes through this, which is 1 ohms. And rather than drawing these two, I can just draw one circuit, one resistor, which is a combined resistor, which is 4/3 ohms. Because it represents the combined resistance for these two. So I can just draw one resistor for that. And then we have 1 ohm. Now, when I look at the simplified picture, I realize that now all of these guys, they look like they're in series, right? Water goes in, current goes in, same current flows through all of them. So now they're in series. So now we can say for this part, I can do the resistance total. That will be 1 plus 1 plus 4/3, right? Okay, 1 plus 1 plus 4/3 gives you 3.33 ohms. Okay, so from that, I can also get my current total, which will just be my voltage total over resistance total, which is 10 over 3.33. That gives me 3 amps. So folks, now I know what's the total amp that goes out. This voltage source pushes out 3 amps. That means I know 3 amps is going to flow through this. It will get split up here. We'll figure it out afterwards. But I also know when it comes here, they're going to join back in. So 3 amps is going to flow through this. Okay. Now what's interesting is I can find the power loss here. One, power loss is, you know what's power, sorry, voltage drop. Voltage drop is I times R, right? So I can do I times R, which will give me 3 volt drop here. I times R will give me 3 volt drop here. Now look at this. My total volt was 10. 3 volts dropped here, 3 volts dropped here. So how much is left? 4 volts. That means the voltage drop across this point, these 2 points is 4 volts. So that means 4 volts is across this. And the same 4 volts is going to be across this resistor as well. And now I have the voltage and the resistance. I can get the current because my current is just voltage over R. So I will do 4/2, which gives me 2 amps. And 4/4 gives me 1 amp. So there we go. 3 amps came this way. Out of that, 2 amps go this way and 1 amp goes this way. Guys, now I know all the voltages, all the amps that flow through all these resistors. They might ask you to find the power total, which is V total times I total, which is 10 times 3, which is 30 watts. And then they might ask you to find the power drop across each resistor. So you can still do VI. So V times I, 3 times 3 gives you 9 watts. 3 times 3 gives you 9 watts. VI, 4 times 2 gives you 8 watts. 4 times 1 gives you 4 watts. And if you add all of them up, they should be equal to the total, which is 30. Okay. So there we go, folks. This is how you're going to tackle these questions. Okay. This is a combined series and parallel question. Okay. So now let's have a look at this question. Okay. In the first question, they've given us a circuit and they're asking us to find the current. Okay. Now, there's another thing I want you to know. Okay. If I give you a circuit, let's say again we have the 10-volt circuit, and we have these resistors. Let's say this is 1 ohm, 2 ohms, and this is 1 ohms. A device that is used to, a measurement tool that is used to measure current is called ammeter. And its symbol is this. This is ammeter, and it measures current. It measures current. And you should know that you need to place the ammeter in series. It needs to be placed in series if you want to measure the current. Means what you would do is, you will take the ammeter, okay, this will be one side of it, this will be second side of it, and this will be the ammeter, and you will just put this in series, okay? So we'll take your wire and you will hook it up on one side right here. You hook up the other side of the circuit to this ammeter. That way what will happen is, when current goes through this ammeter, it will sense it and it will be able to take the reading and it will tell you how much current flows through this. So remember, ammeter measures current and it needs to be placed in series. There's another measuring device called voltmeter, and the symbol is this. This is your voltmeter, and as you know from the name, voltmeter measures voltage. But the voltmeter needs to be placed in parallel to the circuit. Okay, why is that? You should know what is a voltage. A voltage is the difference between 2 points. Okay, so what would normally happen is you might want to measure the voltage drop across this resistor, right? So what you would need is you take one end. Okay, if this is my voltmeter, you take one end and you put it on this side, and you take the other end, you put it on this side, and this voltmeter will measure the voltage difference across the resistor. In other words, it will measure the voltage drop that will happen across the resistor. If you want to measure the voltage drop across both of these resistors, you will put one end right here, and you will put one end right there, and you will put your voltmeter right there. It's in parallel, right? Okay, it's in parallel with that. Because essentially, one end has to go over here and the other end has to come over here. If you wanted to measure the voltage only across this resistor, then you would take one lead of this, and you would take one lead of this end, and then you would measure the voltage. Okay, bottom line is ammeter measures current and it's to be placed in series. Voltmeter measures voltage and it is to be placed in parallel. Okay, that's the key concept. So let's have a look at this question. Okay, they've given you the circuit. First of all, look at the circuit. Okay, this is your voltage source. This is another symbol of the voltage source. Okay, now what happens? Current goes, it goes through this resistor, and the same current goes through this resistor. So tell me something. Okay, we're going to have the same current going through these resistors, right? And what's happened over here? Look, they put an ammeter, and they're telling you that this ammeter is reading 2 amps. And the question is, how much will this ammeter read? Well, the same current is going to flow through this, so this should also read 2 amps, right? That's pretty simple. Now let's have a look at the second one. Okay, now look, your total current is going to come right here. And at this point, your total current gets split up. Okay, some of it goes this way, some of it goes this way. And then when it gets to this point, they combine back in. Now that means your total current goes through this. This is your total current back again, and it goes back and forth. I mean, it goes in a circle. Okay, now look at this. This ammeter, you should realize, what current will this ammeter read? It will read your total current, right? Because you know at this point, both of these branches, the current from both of these branches, it joins. So this will read the total current. And right now that's reading 4 amps. So what that means is total current is 4 amps. So you can say that 4 amps is coming this way. Now they told you that this ammeter right here is reading 1 amp. That means 1 amp goes this way. And what's going to come this way? 4 minus 1, which is 3 amps. So what's this ammeter going to read? 3 amps. Okay. Let's have a look at the next one right here, this one. Okay, so they tell you, they're asking us to find the total voltage. Well, they're telling you that the voltage drop, you see, this is going to measure the voltage drop across this resistor. It's 4 volts. And they're saying, what's the voltage drop across this? Well, guess what? These two resistors are in parallel. So whatever the voltage drop across these 2 points is, nothing is in here in the path. So the same voltage drop is going to be across these 2 points. If this is 4 volts, this will be 4 volts too. Okay. Now, you can draw a combined circuit. Okay. You see the voltage drop across this resistor is 6. Now you might say, and I'm asking you to find the total voltage. So you might say, okay, the voltage total is the voltage drop across all the resistors. So you might be tempted to say 6 plus 4 plus 4. No. Why is that? Because this 4 and 4 is essentially the same voltage, which is across this resistor. You can think of this, you can redraw this, where you draw this as a combined resistor for those parallel. And now you realize your voltage across this, and your voltage across this will be the voltage total right here. This voltage, this voltmeter, it was 6. This voltage, we know it's 4. And this total will be 6 plus 4, which is 10. Does that make sense? So whenever you have a parallel, we know they're going to have the same voltage. So you don't add them up. You just consider them as just one voltage. Okay, think of drawing it as a simplified combined circuit. Okay, guys. So then we have this question right here where they're showing you a bunch of different currents. And they're saying, how much current will this one sense? Well, let's think about it. What's happening over here? Okay, let's say we make this point. Okay, or we make this point right here. How much current is coming in? How much current is coming in? 3 amps is coming in. And you can see 4 amps is going this way. That must mean that we should have 1 amp coming this way. Do you agree with that? Okay, now look at this. At this point, 1 amp is going that way, 4 amp is going this way. Okay, so these are going away. So in total, 5 amps is going away. So how much should be coming in? 5 amps. So essentially, you can take any point and you should say whatever current goes out, you should have the same current, total current coming in. 3 was coming in, 4 was going out, so there must be 1 coming in here. Now, talking about this point, 4 is going out, 1 is going out. So in total, 5 is going out. So 5 amps should be coming in. That's how you determine the current over there. Make sense? Okay, here's a few more questions. Clearly, if you look at this first question, ammeter is reading 3 amps here. This is 3 amps. Now, what's this going to read? Well, that's your total current, right? Total current comes this way. Some of it goes this way, some of it goes this way. 2 amps went this way, 3 amps went this way. And that means total of 5 amps must have come in. So that one's going to read 5 amps. Now over here, voltage across this resistor is 2. Across this is 1. Across this is what we're trying to find, but we know the total is 6. So you do 6 minus 2, 4, minus 1, 3. So 3 volts must have dropped across this resistor. Because the total voltage drop across each resistor should be equal to the total voltage. Okay, same over here, they're saying voltage drop across this resistor was 4, but voltage drop across this resistor, which is in parallel to both of them. Now look at this. This is telling me that the voltage drop across these two is 6. That means voltage drop across this 2 should be 6 as well. Well, 4 is dropping around here, so 2 must have dropped here. Okay, and the total will be, okay, you just take these parallel circuits, combine them, it will just be 6 volts, right? So there's a 6 volt difference here, 6 volt difference here. So there's a 6 volt difference here, so this is 6 volt. Okay. Same for this one right here. You can make a point here. You can say 3 amps are coming in and 5 amps was going out. Okay, so there must have been another 2 amp coming in. So for this point, 2 amps is going out, 2 amps is going out this way, then 4 amp must be coming in, right? So on this side, 4 amps must have come in. So this will read 4 amps. Okay, let's have a look at these ones now. We have, this is the total current, because I know what happened. Total current came here, got split, combined back in, and the total current flows through this all the way. So that's my total current. Now, this one measures 3 amps is going through this. So this one must be 2 amps. Okay, pretty simple. Looking at question number 2. This is total voltage of 12 amps, 3 volt dropped here, 2 volt dropped here. So total of 5 volts has dropped there. So leftover is 12 minus 5, which is 7. That means there's 7 volts left. So voltage difference between this is 7. So that will be 7 volts, and this will be 7 volts too. Okay. Now we have 5 amps coming here, 3 amps coming here, 1 amp coming here. So the total is 5 plus 3 plus 1, which is 9 amps. And 2 amps is going this way. So 7 amps must go this way. Okay. And you use the same thing over here. Okay. 2 amps are going away. 4 amps are coming in. So there must be 2 amps going away. Same for this. Now, you know, 2 amps is coming in. Okay, let's look at this point. 1 amp is coming in. 3 amp is coming in. So 4 amps is going out. Now, 4 amp is coming in. 2 amps is coming in. 6 amp must go out. So this is 6 amps. Okay, so let's have a look at this question now. They have given you 18 volts right here. Okay, now this ammeter is showing 1.5 amps, means that's your total current. Okay, so we can say my total current is 1.5 amps. So we know the current that goes through this resistor is 1.5 amps. And current through this resistor is 1.5 amps as well, because it's going to combine back here. So now what we can do is we can find the voltage drop across each of these resistors, voltage using IR. So that will be 1.5 times 3, which is 4.5 volt drop here. 4.5 volts. And voltage over here will be 5 times 1.5. 5 times 1.5 is a 7.5 volt drop here. My total voltage is 18 volt. So 18 minus 4.5 minus 7.5 gives me 6 volts. So there must be 6 volt across this and 6 volt across this because they're in parallel. What's the current going to be going through this resistor? Current is V over R. So 6 over 6 gives me 1 amp, goes this way. Okay. Now we know the total current was how much? 1.5 amp. If 1 amp goes this way, 0.5 amp must come this way. Right? So what's the resistance? Your resistance is V over I, which is 6 over 0.5, which is 12 ohms. This is how you're going to solve the circuit. Okay. So there we go. Okay, we found the resistances, all the currents, all the voltages. Now, to find power total, you should know your power total is just V total times I total. V total is 18, I total is 1.5. Times them up, you get the power total. If you want to find the power across each of the resistor, just use VI at each of the resistor. Okay, now they're asking us to solve this resistor. Well, let's see what's given to us. Look at this. This ammeter reads 1.2, and that is your total current. Okay? So we know the total current that is going to go through these resistors. Okay. Now another thing to keep in mind. Okay, we know the resistances here. We can combine the resistances. Okay, these are in parallel. These are in parallel. Okay, you first combine these two and draw them as a single resistor. I'll give you another trick. if you have two equal resistances in parallel, their combined resistance will be half of it, which is 10 ohms. You can use the formula and you will find out. Same over here, these two resistances are in parallel. If I combine their resistance, it will be 5 ohms. So when I redraw the circuit, it will look like this. I will have just one resistor here. We have just one resistor here. And we have one combined resistor here. This combined resistance is 10 ohms. This is, we don't know this one, right? This is what we're trying to find. And this one right here is 5 ohms. And total voltage is 24. And the current total is 1.2. So we know 1.2 amps goes through this, 1.2 amps goes through this, and 1.2 amps goes through this. So we can find the voltage drop across this resistor. Okay, voltage is IR. So 10 times 1.2 gives me 12 volts. So 12 volt drops here. And using IR over here, we do 5 times 1.2, which is 6 volts dropped here. Total was 24. 12 dropped here, 6 dropped here. So we do 24 minus 12 minus 6 is 6. The leftover voltage is 6. That must be the voltage drop across this one. Okay, so we have
for example, the 12 voltage is for the combine of both of them, right? That we added.
That's right. That's right. Yeah, combined. But I've drawn this as a combined resistor. But now this is a series circuit.
Yeah.
Okay. So technically, this 12 volt that I found is 12 volt here, and the same 12 volt is here, because you know the parallel ones are going to have the same voltage, and that means we have 6 volt here. For if this was 6 volts, right? So there will be 6 volt on this, because parallel resistors get the same voltage. Okay. So when it comes to parallel resistors, you think of their voltages as just one voltage, because it's going to be the same thing over all of them. So when you're adding all the voltages, you don't take both of them, you just take one. You think of them as a combined resistor. The best thing is to draw a simplified circuit with the combined resistances. So 12 volt dropped here, 6 volt dropped here, total is 24, so this must be left over, which is 6 volt. And then I can find the resistance, which is, your resistance is just voltage over I, which is going to be 6 over 1.2, which is 5. So this resistance is 5 ohms. Okay, so there we go. We found all the resistances, all the voltages, okay, all the currents. You can find the power total. You can find the power at all of the resistors now. Okay, so now let's have a look at this one. Okay, first of all, this right here, it's telling me the total current. Okay, I know the total current right here. Okay, so let's see. Guys, what happens is this total current is going to come in and it's going to get split up right here and right here, right? And then it comes here, it further gets split up right here and right here. So let's see what we can work out over here. They gave us this voltage. This voltage is 30 volts. That means this voltage is 30 volts. I have the voltage and the resistance, so I can get the current going through that. That will be 30 divided by 24, which is 1.25. So current on this resistor is 1.25 amps. The total current is 6.25. Okay. The total current is 6.25. Remember that. Okay. So this is 1.25. Let's see what else we can figure out here. Okay. This is a tricky one. Okay, guys, now look at this. We know the voltage difference here is 30. So the voltage difference between these 2 points is 30. That means these 2 points is 30. These 2 points is 30. That means this 2 point is 30. So voltage difference on this resistor is 30. Okay, so we got 1.25. And then we can say voltage difference, that means across these 2 points is 30 as well. So voltage difference on this resistor is 30 as well. Okay, voltage difference on this is 30 as well. So now we can get the current on that one too. 30 divided by 12 gives me 2.5. Okay, guys. So now look at this. We know 2.5 came this way. We know 1.25 came this way. Therefore, the current coming in here should be 6.25 minus 2.5 minus 1.5. So 6.25 minus 2.5 minus 1.25 gives me 2.5. That means the current that goes on this resistor is 2.5. We know the voltage, so we can get the resistance. That will be V over R. So 30 divided by 2.5, which is 12. So we know R3 is 12 ohms. Okay, there we go, folks. We found all the voltages, all the currents, all the resistances, and we can find all of these values now.